All right, so one more video on our intro worksheet to 3.3 where we'll use some of the properties to kind of change the way logs are written or expand or condense. So I'm going to start with number 5 here, where we have to use properties to express this ln of 9/8 in terms of the natural log of 2 and natural log of 3. And I'm just going to start off by rewriting this using our quotient rule, quotient property, that division can turn into subtraction. So we can rewrite this as ln of 9 minus ln of 8. And then we want to try to get base 2 and 3. So 9 we can write as 3 squared, and 8 we can write as 2 to the third. And then finally we could use our power property to move those exponents out front and end up with 2 ln 3 minus 3 ln 2. So kind of using our expanding rules for logs, right, to make these into 2 separate logarithms with the smallest value we can have integer value in there. For number 6, I'll just get you guys started on this. Think about how else we can rewrite 5.4 and as a fraction 5 4/10 or 54 over 10, right, to get that 5.4, and then skipping around. But from there, I want you guys to try to simplify it just like we did in number 6, thinking of first simplifying your fraction and then rewriting with that base. 7, I think will be pretty self-explanatory now that we have the properties. You don't really even have to use our expand and condense for those. So you guys can give that a try on your own. I'm going to move on to number 8. We're expanding each log, and I'm just going to start off by separating all of those values in the log. So the 200, I'm going to do log 200, and remember addition. So we'll add all of those values up in the numerator, and all those are being divided by the square root of 4x plus 1. So that'll be subtraction. And I'm going to rewrite 4x plus 1 square root to the 1/2 instead, so we can take that out of that logarithm. So last thing I'm going to do is just take all the exponents out, and I can simplify this log 200. So sometimes my directions will say with the smallest integer value in the logarithm. And it's kind of hard to, I don't know, explain what I want here because we could keep breaking integers down. But if there's a base, like log 10, and we can break out a base 10 from 200, which we can do with 100, then that's one that we can simplify. I'd usually specify like only log 2, like right in terms of log 2 and other values or something like that. But this one just showing that we can split it into log 2 plus log 100, and then log 100 will be 2. So I'll have log 2 plus 2, right, because 10 to the second power equals 2. All of those other values up here, I'm just going to move those exponents out front. So again, feel free to slow down the video, stop it, pause it, or maybe try these on your own first and then come back here if you need some help with those. So I'm just going to let this run for the second one. Same idea. Just remember if there's 2 things in the denominator, right? So I wrote the denominator separately, subtraction. Both of them need to get subtracted from your original. So that shows they were both being divided in the first equation. And then move those exponents out front, or radicals. All right, so I'm just going to do one of these condensed problems, and then I'll put the answers here for the others, but you guys should try them first out on your own, and even now, maybe try this out on your own. Just that first one, even the integer we want to write as a logarithm, so think of how we could use log base 3 to write 2. Maybe some of us can just go right to it, but one of the options is thinking of log base 3 of 3 as like multiplying by 1, and then that 2 I can just take and throw it up in the exponent. So I really have log base 3 of 9. And now I'm going to do everything else we have there. So still minus that log 3 of x plus 6. Whoop, I skipped the x to the 4th there. Have it for us. And moving the coefficients into exponents or radicals. So I erased our log base 3 and 9 because I'm going to put everything together right now. So I'll have log base 3. 9 gets multiplied by the x to the 4th because that was addition. And then we're dividing it all by the cubed root of x plus 6, which I really made look like a b. Maybe I'll take that out and fix that guy. x plus 6. Remember, we don't rationalize radicals when it's not numeric values in there, so we'll just leave the variables in there. I know sometimes the book does otherwise, but it'll save us work, and we won't be changing the domain. Okay, so I'll put the other answers here. I lost my L for my log there. I'm actually just going to kind of fast forward this for us. So if you haven't yet, I would pause this, try them out, check your answers with these or the answer key online. And I'm going to do just one last problem, number 11. I'll just do it on a blank slide. I don't have this one written ahead of time, so it might take a little bit longer. But for this guy, write log base 3 of 6 times log base 6 of 13 as a single logarithm. And the hint to this is it's after in number 10, it says change of base. So really, change of base, we have to remember, splits this into two logarithms where one log is the argument and the other log is the base, uses the base as the argument. So I'm just going to start with that for both of these, rewriting this as log 6 divided by log 3, and we're multiplying this by log 13 divided by log 6. So maybe now we see what's going on. Since my base and my argument were the same, those can cancel, and I'll get log of 13 over common log of 3. And when we have the same base being divided, we can use our change of base to go back into one log. So my bottom number goes to the base. I always think the base goes to the basement. And then my numerator goes there. So that will be 11a on our 3.3 intro worksheet, writing as one logarithm. All right, guys, feel free to check out the book if you need any other information, and we will go over more questions next time.